Hello, everyone. Hopefully you can hear me okay. I'm Justin Silver. Thank you for the great introduction. And I wanted to just recognize my colleague who's also here, Yan Shu. So she's also here from Pros. And we're just down the road off Main Street, not too far. And so we're happy to be here today. And I know I'm the only one standing between you and lunch, so I'll try to be cognizant of that as I go through this. So a little bit about Pros. I just wanted to give you the backdrop of who we are and what types of problems that we solve, what types of industries that we serve. So ultimately, Pros is all about modern commerce. That's what we call our initiative, but it's really all about taking business processes and modernizing them according to the times. So leveraging data science to enable businesses to achieve their goals in terms of profit, in terms of margin, in terms of revenue, all of those things. So a little bit more detail about Pros. We have a little over 1,000 employees worldwide. And we've got a very extensive innovation core in terms of our data science. So our science group is pretty extensive, but I'll get to that in a little bit. But I just want to talk a little bit about our industry coverage. So we got started back in the late 80s with the airline industry. Southwest Airlines was actually our first customer. Once the airline industry was deregulated, there was a lot of opportunity for airlines to decide what price to charge. And so you might wonder, well, okay, why is the price for this flight this today versus what it was yesterday? And so you're welcome for that, I guess. It's really up to us. It's not my fault, okay. So airlines is how we got started, but we since have expanded because a lot of the underlying technology is very applicable to other businesses, because what it comes down to is finding the right price under the right selling conditions for that particular buyer. Right? And that's what the ultimate goal is to be able to address that business problem. And so we do that across all these industries, right? Manufacturing and the B2B e-commerce, which I'll be diving into a bit more today, and some of these others that I've listed here. So I wanted to motivate the problem. Before I do that, a little bit of a plug for our science team, because we're great. We've got a little over 20 on our staff. Again, myself and Yan are part of that team. And again, just down the road off Main at Pros. And we span the gamut of a variety of technical backgrounds: statistics, operations research, math, et cetera. So come check us out if you're interested. I want to motivate the problem, like I said, a little bit more. And you've probably heard of a recommender system. If you haven't heard of the term, you've definitely come across it in your everyday life, because whenever you go to Amazon, if you use Netflix, it's always telling you, hey, you might like these movies, or you might like to buy these items based on your previous purchases or based on similar customers, right? So recommender systems are all around us. We're always interacting with them. I want to distinguish for you the difference, however, between recommender systems that we build versus the ones that, say, Amazon and Netflix do. And that's really important, and a key distinction is we are in what we call the B2B world, which is businesses that sell to other businesses. And Amazon and Netflix are more targeting the end consumer, the individual. Now, some of our solutions, some of the things that we do are targeting an end user, an end consumer. But a lot of the business that we do, a lot of the solutions that we put together are for the B2B space. So how do these differ? How do these differ, right? So B2B, so as you can see from the first two bullet points, I mean, the problems are very much the same in a lot of ways. You're giving product recommendations for individuals that are personalized. Where it comes to be a bit different for B2B is that you're not personalizing for the individual, you're personalizing for an account, which is a business, right? If I'm a food distributor and I sell to McDonald's, McDonald's is one of my accounts that I'm selling to. So in determining what products that I want to offer McDonald's, I'm not really worried about the individual person that's buying. I'm worried more about what McDonald's buys and what types of products they'd be interested in. The other thing is that it has to be industry relevant. So it's not that you can span the gamut of all possible products that you can offer. You have to really target the offers at whatever industry that you're trying to sell to. And that's another key distinction, again, between the B2B and the B2C world. So again, it's individual shoppers, plus these business accounts that I was talking about. And then there's the restriction on the products, right? The catalog of products that you can offer is more constrained because of the industry needs and the needs of specific businesses. And you have different levels, different potential levels of an account. And so depending on that level of an account, you may have to personalize to those different levels. And there's also, in the B2B world, there's price negotiation. And that's also an area that Pros is pretty big in, is figuring out how to support a salesperson in negotiating a price when they're working with a customer, giving them prices that are derived scientifically from data. and enabling them with support based on information that they've seen, what prices are they actually likely to win with when selling to that customer. And it's really trying to understand that customer's buying behavior to do that. And then the buying cycles, right? So typically when you're going to buy something on Amazon, it's pretty quick, right? Pretty quick turnaround. But with these B2B interactions, a lot of times you're talking about sales cycles that go on for weeks, sometimes months. And so again, the cadence of delivering insights to the salespeople is dependent on that buying frequency. So these are some of the high-level distinctions between these elements here. So how do we solve the problem? Well, the solution is something we call opportunity detection. And so really the motivation for that is that a lot of sales reps, and these come from a variety of sources that they kind of do some market analysis and identify opportunities in these types of industries, that almost 90% of sales representatives miss opportunities because they just have so much information and they don't know how to manage it, right? They get so many accounts. So like if I'm a sales rep and I have 1,000 or maybe even 100 is a lot, 100 accounts, right, that I'm overseeing. And a lot of these big companies have that number of accounts that they're managing. It's huge. And the number of products, right? I could be selling tens of thousands of different products. So how do I know what to sell to whom and when? Right? So that's a very big problem for these businesses. And they spend a lot of time doing research, right? I'm a sales rep and I'm trying to figure out what to do. How do I mitigate that issue? How do I figure out what to sell to whom? So I'm spending most of the time researching, and I'm a salesperson, so I'm supposed to be selling. Most of my time should be selling, not researching. So we want to address that as well. And we also have seen that we can drive quite a bit more revenue for customers that are buying multiple products versus just a single product. And we see this in the realm of kind of between a 6 and 20 multiplier on that. So our solution is really identifying purchase trends and purchase patterns in data and surfacing those as insights to the sales representatives so they can act on them in a timely manner. And so we have 3 different primary types of opportunities that we can derive. And I'm not going to dive into the details of how we get into each of these 3. And certainly these are not the only 3 types of insights that can be generated. But just real quick, declining meaning, I mean, it's pretty clear from the picture, I think, but you're seeing a trend of decline over time based on the fact that this customer is just not buying as much of that product as they had been in the past. So you might want to know that. And that's something in the business realm that we would call churn. So customer churn. And so this is something that we would identify with that particular model to identify customer churn and then show that to the sales representatives so they can recognize it and be ahead of it. Maybe it means a phone call, maybe it means a discount, right? There are various ways that they can help address that. Inconsistent buying, again, the picture I think speaks for itself. I mean, it's outlier detection at the end of the day. It's finding anomalies in the customer's buying behavior that would indicate that there is something going on. Either they maybe bought something once from you because they typically buy from one of your competitors, and maybe the competitor was out of product at that time, so they came to you. I mean, there are a number of underlying reasons why this could happen, but ultimately we want to just identify these things and surface them up to the end user, to the sales representative. The one I'm going to highlight most is the gap. And I think my pie chart with the missing piece is probably an indication of what I'm talking about. Is there's a gap in what the account is buying. And we see that because of what other customers that are similar to this account are buying and based on the products that this account is already buying. And so we see that there's a gap in their portfolio that we can potentially fill. So I want to dive more into the gap pattern and how we get at that. So this is essentially the flow of how we determine gap patterns. These you can think of these as the closest to the product recommendations that you get out of, say, Amazon, right? So customers who bought this are also likely to buy that, and then based on your previous purchases, you're also likely to buy these products. So it's really done at understanding the inputs, I guess, is important. The input data that we get is seeing purchases from customers and what products they bought, how much of the product they bought. So you can think of that as a transaction, right? Transaction data. So it's on a specific date, they bought this product and paid this amount. So you achieve this much revenue. So that's the input. Now, and this kind of gets back to that distinction from the B2B to the B2C world, is that we need to localize the search, the space of all the products that we're searching across. So it's that restriction of the product catalog that I was talking about. Right? I can't just look across all products that I'm selling and think that all of those products are going to make sense for that customer. I have to know what types of products is that customer likely to buy. In order to do that, I have to identify a peer group for that customer. And I'm actually going to dive even a level deeper on that peer group analysis and how we get to that. Who are those peers of this customer? Because it's an interesting problem, I think, especially for this audience. I think you'll find it pretty interesting. But ultimately, once we do that, once we figure out, all right, who are these like customers similar to this particular one? Who are these peers? We can figure out, all right, well, what are all the products that these peers have purchased, right? And these are our potential recommendations, our potential complementary products, if you can think of them like that. So from there, it's really about a couple of different things. So typically, you might see a recommender system that's looking at just one measure. And that one measure might be a conditional probability. So the conditional probability is, given that you've purchased this product, what's the probability that you'll purchase this complementary product? And that ultimately can be pretty much the essential kind of core of the calculation, is that conditional probability measure, which makes sense, right? Given I've purchased that, what's the likelihood I'll purchase this other product or these other products? Now, that's great. However, it's kind of missing some of the story. And that other part of the story is what we address with this other piece here, which is finding buying patterns. So we actually build out vectors of the amounts, either in revenue or volume, based on how much of certain products that are being bought by customers. And we look for correlations between those. Because it's not just about, all right, well, what's the likelihood that they'll purchase this product, but are they buying that new product in a similar ratio to the product that we're referencing, like the source product, right? So given that they're buying peanut butter, the likelihood that they'll buy jelly, that's great that they're likely to buy jelly, but are they buying these things in a relatively predictable ratio that it would make sense to offer this product to that customer? So there's these two components that we then end up blending together. So they score 1 and score 2, right? The complementary purchase probability and the correlation of the buying patterns that come together in this final weighted score. And at the end of the day, what we get out of this is a ranked list and the output of these are the most likely complementary products or gaps that we can fill for this customer. So as I talked about, I wanted to dive even just a bit more into the peer group, because I think that part of the problem, I mean, there's a lot of underlying science here. There's a lot of algorithms. I already said the declining, the inconsistent. I could talk about those. I could talk about how, more specifically about this algorithm itself. I just wanted to give you an idea of the solution and the flow. But in terms of the approach, I wanted to dive just a bit more into the peer group analysis. So customer peer groups for the gap patterns. So what we do is, so we don't have a target variable here. We don't necessarily have something that we're trying to predict. All we have are what customers bought in the past. So we may have some features and characteristics of the customers. Say they may belong to a certain industry, which could be, say, a feature that we would consider in the model. But at the end of the day, we don't have a target. So it's an unsupervised learning setting. So we're doing clustering. And so basically what we're doing is we're trying to group together these customers that have similar purchase behavior. In other words, their portfolio of products is very much similar, right? And so the clustering enables us to do that. And one thing that I'll note is, based on this diagram, as you can see, there's kind of a little bit of a hybrid of some business-driven constraints going on, along with some scientific processes. Because you may want to say, well, I know I can break my customers up by a certain industry, restaurants, schools, hotels, et cetera, a certain customer type. And then from there, I can actually run a clustering algorithm, say it's k-means or it's hierarchical clustering or some combination thereof, and I can actually get more granular groups within those high-level business groups. So you don't have to do that. You could just apply the clustering techniques across all the customers. But what this does is it makes the model a lot more explainable. And one of the things that we see, we do a lot of machine learning, we deliver a lot of machine learning solutions to customers, is complex methods are great, but we have to be able to expose and explain a lot of times to the people that we sell to. Because again, in this B2B world, the sales representatives, the pricing analysts, all these people, all these personas that we target, they want to know, how does it work? And to be able to explain it is sometimes a challenge. So things like this enable you to kind of bring that business in with the science and you merge the two, and it kind of finds the happy balance between them. So I'm not going to describe in detail. Unfortunately, I'm very limited on my time of the clustering methods and some of the metrics that we use to evaluate those clustering methods. We use a couple of different clustering algorithms here and a variety of metrics to assess the quality of our clustering. But one interesting aspect of this problem is the construction of this account by product matrix. So ultimately, the input to recommender systems is a matrix, and we do the same thing. So we start with the input data, and as I mentioned, the input data is customers and products, right? Who are the accounts? What are they buying? How much of it are they buying? So it's pretty simple input data, right? 3 elements. So you can see I've got 3 different accounts here. They're buying from these 3 different product categories, and I'm showing you how much revenue they've spent in those categories. So it's a pretty straightforward transformation to widen out this matrix, and I'm essentially out of that building an account by product. So each of those products gets its own column. You can see I've filled in the missing values with zeros. You could debate as to whether that's a wise thing to do, but in this case it happens to work quite well. And so I've got 3 rows here for my 3 accounts and 3 columns for my 3 products. As you might imagine, we see a lot of cases where we have more columns than rows in this situation because tens of thousands of products potentially and thousands of accounts, so that scale could potentially be a problem. And there's a lot of sparsity. There's a lot of sparsity in this matrix, as you can imagine, because if you think of the Netflix case, like you're not watching and reviewing every single movie. And Amazon, you're not buying every single product. So how do they come up with those recommendations? Well, that's the same challenge that we face in this scenario, is the sparsity of that matrix. So an important aspect to this matrix is, well, the scale, right? If we're going to do k-means clustering, especially if we're going to use the Euclidean distance, we have to scale. We have to normalize the columns, the rows. There are a variety of ways we can do that. You can think of row-wise, column-wise normalization. An interesting analogy is text mining. So in the world of text mining, where you're trying to cluster documents, right? So you have some count of term frequency that you're trying to utilize to, say, group similar documents together based on that. And so this measure that's called TF-IDF, which stands for term frequency inverse document frequency, is actually a fairly common metric that's used in text clustering that enables you to cluster documents together that are similar to each other based on the words in them. But it's not just looking at word frequency, it's also looking at, are these words common across all the documents? Because if you have words that are common across every document, then they're not helpful in distinguishing one document from another, and these clusters aren't very easily distinguishable. I mean, certainly, keywords, articles and such, like you would remove those anyways, but you can imagine if you use words like the and if you were to do that, a lot of these documents are going to have those, and almost all of them, and every single one probably would. So you're not going to be able to get good clustering out of that. So this normalization actually is very useful in our application as well, because we're really trying to get at the same thing, except in this case, the first term of the computation here is what percentage of that amount of revenue that the customer is spending overall is on that particular product. Right? So I can scale and normalize by that factor. And then the second term is more of a penalization, and it's you take the log of that ratio, but basically it's getting at what is the overall uniqueness of that particular product, and does it help distinguish this cluster from that cluster? And so you can see the closer that ratio gets to 1, of course, that will dampen down those particular features. So as I mentioned, we're a software company, or I don't know if I mentioned that, but we are a software company. And so the solution is actually in a production system. I just wanted to give you a little bit of a sense of what that looks like from a business perspective, how someone might use this. Right? I'm a salesperson, and this is a typical workflow that a salesperson for a B2B organization would use. This is called the CRM system, Customer Relationship Management System. There are a variety of these. Salesforce, if you've heard of that. There's also this Microsoft Dynamics, which I'm showing here. But basically, it helps the salesperson manage all of their accounts, all of the deals that they're working on at a particular time, and track those over time. So we can take the information that we've generated here, all of the insights, right, those declining trends, the inconsistent trends, the gap patterns, all that analysis, and bring it together in a way that a salesperson can very easily consume and act on it. So I see here, this is one particular account. So I'm a sales rep, and I'm responsible for this account that's Max Food Wholesale. And I'm seeing here, what are my top 5 opportunities that came out of this analysis? And they're all ranked in terms of how much revenue I can expect from those. And so I zoomed in just on one of those so you can see a little bit deeper. So in this case, it's a declining trend, very easy. You can see from the picture that it is. And what I can actually do as a salesperson is I can click this button. It's not a live demo, but if I wanted to, I could say, hey, you know what? This looks like a good opportunity. I'm going to click that, go ahead and create an opportunity, and then it's going to automatically go into the opportunity list that I'm working on so I can manage that, right, and track that. Or if I don't like it, I can reject it, and then that feedback will go into the system. It will update the model based on the feedback that it gets, and it'll eventually, hopefully, get those recommendations more tailored to that salesperson. Okay, so thank you for your time.
Thank you. We have time for one question.
The question related to B2B, right? This is good for medium corporations, in fact, the small corporations too. But what about the startups where they don't have this luxury for going on B2B, where they have primarily on the primary market research, which is B2C? So, what are your thoughts on for the startups?
For startup companies? Yep. Yeah, so it's challenging when you don't have a lot of history to start with. But the modeling is flexible in the sense that you can kind of set up the system to learn from user feedback. So the more transactions that will occur and the more feedback that the user gives the system, it'll actually learn from those interactions and adapt. And so then the recommendations that come out will eventually get better. So initially you might not get very many recommendations, and they might not be very good. But the idea is the framework is there to learn over time so that you can actually adapt to that.
All right. And last thing before lunch, let's thank our speaker.
Thank you.